In this video lesson, we will learn how to solve root equations. You can take a look at my video lesson, Domains of Root Functions, to find out other things about roots. But in this case, we're just going to solve equations that have square roots in them. More specifically, they don't just have square roots in them, but they have square roots with an x or a variable inside. So for example, the square root of x plus 1 equals 3. What is x equal to? Well, the trick is that the opposite of a square root is a square. So what you want to do is square both sides. And you're doing the same thing to both sides, so it's allowed. And you get the square root disappearing from taking the square, and you just get x plus 1, and 3 squared is 9. So you get that x equals to 8. It's pretty elementary to check that 8 plus 1 is 9, and when you take the square root of 9, you get 3. So we'll just move on to the next example. There are many different types of root equations that you might encounter. So this is going to be another type. And the square root of 2x minus 1 equals x plus 1. So earlier we had a square root of something with x in it equaling to just a number, but now we also have an x outside of the square root. What does this do? Well, for the first step, we still just want to square everything because we want to get rid of the square root. So we get 2x minus 1 equals 2. And now on the side, I'm going to expand x plus 1 squared. We just used FOIL. It's going to be x squared plus x plus another x plus 1. So, in other words, x squared plus 2x plus 1. So now we replace x plus 1 squared with this expression in our equation. So we get 2x minus 1 equals x squared plus 2x plus 1. So now we got to simplify. How do we do that? Well, in this case, it's easiest just to move the 2x minus 1 to the other side of the equation. So what we're going to do is we're just going to subtract 2x minus 1 from both sides. So minus 2x and plus 1 on both sides. The left-hand side just becomes 0. And on the right-hand side, we get x squared. The 2x plus and minus 2x cancel, and then just plus 2. So get 0 equals x squared plus 2. All right. So where do we go from there? Well, here we encounter sort of a problem. The problem is that x squared plus 2 equals 0 means that x squared equals to negative 2. That is, x squared equals to a negative number. The problem is that x squared has to be positive. So what this means for our equation is that there are no solutions. That is, no real solutions. So sometimes in root equations we just won't have any solutions at all. Now let's do another example. This example is going to have 2 square roots in it. More specifically, we're going to have square root of 2 minus x equals 2, square root of x plus 4. This is actually going to be one of the easiest examples, because now we're going to square both sides because we want to get rid of the square roots. And when we square up both sides, the square roots disappear, right? So all we get is 2 minus x equals x plus 4, a very basic standard linear equation. So we just add x to both sides. We get 2 equals 2x plus 4. This is isolating the variable. Then we're going to subtract 4 on both sides to get rid of the 4. And this is going to turn out to be negative 2 equals 2x. And now we just divide by 2, and it becomes clear that x equals negative 1, or negative 1 equals x. So this should be our answer. Now, one important rule with root functions is that you always want to check your answers. I'll explain why that is so important later. But for now, we're just going to plug in -1 and see if it works. So we have 2 minus -1 and -1 plus 4 inside of the square roots. So square root of 3 equals square root of 3, which is obviously true. So it's all good. Now we're going to move to our next example. All right. So in this example, we're going to take 30 minus root of 30 minus 2x equals x minus 3. So again, we want to square both sides. So of course the square root's just going to disappear, but the other side we need to FOIL out. So here I'm doing that. Get x squared minus 3x minus another 3x and plus 9. So x squared minus 6x plus 9. So we have on the left-hand side 30 minus 2x equals x squared minus 6x plus 9. So we're going to have to pretty obviously deal with a quadratic equation here. So let's move everything to one side. To do that, we're just going to subtract 30 minus 2x from both sides. So on the left-hand side, we just get 0. And we get 0 equals to x squared minus 6x plus 9 minus 30 and plus 2x, because two negatives make a positive. So now we're going to combine the like terms, that is, the x's and the constant terms, and we get x squared minus 4x minus 21 equals to 0. Now in this case, this quadratic equation just factors. For more about solving quadratic equations, you can look under my video lectures with those names. So this will factor as x minus 7 times x plus 3 equals 0, of course. So what this means is that either x minus 7 equals 0 or x plus 3 equals 0. So x equals 7 or x equals -3. Now we're going to see why it's so important to check answers. We're going to check both of these answers individually now. So first, x equals 7. Our original expression is root 30 minus 2x equals x minus 3. So if we plug in 7, we're just going to replace all the x's with 7's. Then we get root of 30 minus 14 equals 4. And 30 minus 14 is just 16, so get root 16 equals 4. Well, this is of course true. The root of 16 is equal to 4, so I have 4 equals 4, a true statement. So x equals 7 works. Well, let's see what happens when we plug in x equals -3. So again, our original expression I've rewritten. Now we're going to replace the x's with -3. I have 2 times -3. And so this simplifies to root of 30 plus 6 equals -6. Or square root of 36 equals -6. But this means that 6 equals -6, which is false. So what we have is called an erroneous solution. The only real solution, the proper solution, is x equals 7. And that is why we have to check the answers. I hope you found this video lecture helpful. Thank you for watching.